you remember this?
Yes.
Yes? So explain it.
So the
How many cells do we have? How many type of cell?
Great.
In action potential wise term, how many types of cells do we have?
Two.
yeah.
What do we call it?
Muscle cell, myocardial cell.
No,
And this is
No.
another one.
no, we are talking about action potential.
And
How many types of action potential do we have?
two.
Is slow action potential,
Fast.
fast action potential.
Sodium.
Is slow and fast. So based on the action potential type, we have two forms of cells. Fast action potential,
Slow.
fast action potential can be seen in normal ventricular and atrial muscle cells. A slow action potential can be only seen in sinoatrial node or sinoauricular node, atrioventricular node, and Purkinje fibers. Can you remember?
Yes.
So, a slow action potential, fast. In the normal atrial and ventricular cells, we have
Fast.
fast action potential. In atrioventricular AV node, we have
Slow.
so normal atrial, normal ventricular are Purkinje fibers, fast action potential. In SA and AV nodes, we have. Let me start with fast action. Fast action potential has 5 phases. Phase 0, rapid depolarization. Phase 1, early repolarization. Plateau, depolarization, and rest. How many phases does it have?
5.
5 phases. Resting, fast depolarization, early repolarization, plateau, repolarization.
Rest.
In slow responses, we have just 3 phases. Depolarization, repolarization,
Rest.
and rest. How many phases?
3.
During
number 2 in the fast is like rest. Is the number 2 in the fast is
number 2 is plateau.
plateau?
Plateau. I will discuss. At rest, if you put 2 microelectrodes inside the cell and outside the cell, you can record minus 90, minus 100, minus 102, something like that. On most of the books, minus 90 millivolt, the potential difference between inside and outside. What is the difference between outside and inside potential?
Minus 90 volt. Minus 90
Yes.
volt.
So what is the reason behind that? What do we have different electrical potential inside and outside?
Because there's different concentrations of ions.
So what is the reason? What is behind that? What actually produces the electrical
I think
potential?
it's because outside there's sodium.
We have high amount of sodium outside and high amount of potassium inside. What is the reason? Why do we have higher ion concentration outside and inside?
Because pump of the cells. Pump. That's
So, due to the presence of sodium, potassium, ATPase. Sodium, potassium, and ATPase pumps 3 sodium out and 2 potassium in. So the charges concentration outside and inside are different. We have high concentration of calcium outside, low concentration of calcium inside. 10 to the power of 4 means 10,000 times calcium is greater outside than
Inside.
2 times 10 to the power of minus 4 is the intracellular concentration of calcium. I mean, it is almost 10,000 times low calcium inside the cell. Why? Because there is a special calcium ATPase. Calcium pumps out. So inside we have minus 90 millivolt at rest. This minus 90 millivolt is stable in fast response cells. You have a straight line at rest. When there is a stimulus, this voltage difference will be changed. And if you bring some positive charges inside the cell, this minus 90 millivolt will be increased. From minus 90, if the membrane potential reaches to minus 65, then sodium channels will be open. And sodium will rush into the cell. And you will have a burst of ion movement. The charge will reach to 0 and overshoot. Plus 20. This is minus 65, which is called threshold, due to the opening of sodium, fast sodium channels. At rest, the cell is impermeable to sodium channels. At rest, the cell is permeable just to potassium ions. Potassium ions. So, when there is a stimulus, sodium channels will be open. As you can remember, sodium channels has 2 gates. One is activating gate and the other one inactivating gate. M and H. At rest, M is closed and H is open. This is at rest. When a stimulus comes into the cell, M is open, sodium rushes in at minus 65. M is open, it is voltage dependent for opening and voltage and time dependent for closing. When both gates are open, sodium rushes into the cell. After some time, H gate is closed, but M gate is open. This conformation change is called inactivation. See, this is activated, inactivated. After some time, the M gate will also close. This is called closed state. Inactivating. See?
Doctor, what's mean M and H?
Hold on.
M and H.
M is called activating gate, H is called inactivating gate. When both are open, this is called open state. When H is closed, this is called inactivating state. When both are closed, this is called closed state. And then, after some time, near the end of repolarization, the H gate is initiating to open at the end of repolarization. The H gates is initiating to reopen again. And at this time, if you apply a stronger than normal stimulus,
It will open.
it will open. And the cell will respond. At the end, near 0.03 seconds at the repolarization. If you apply a stronger than normal stimulus, the H gate will be open. They are trying to open. If you apply more stronger stimulus, then both M and H gates will be open and sodium rushes into the cell. This is one reason for ectopic rhythm. Ectopic means before than normal time.
Is this logic applied for all cells or just cardiac cells?
Not all the cells, but excitable cells like the heart. We have the same situation in the nerve.
Except the cell point in SA node.
We have the same situation in the same.
Yeah.
We have the same
But all
situation.
the cells in the heart.
In the heart can be early re-excited
Yeah.
based on this scenario.
Yeah.
So, now listen. So, during phase 0, fast sodium channels will be open. You have a fast response, see? From minus 90 to minus 65, which is called threshold. Then the membrane potential will fast reaches to plus 20. From 0 up to plus 20, it is called overshoot. Then, after some time, sodium channels will be closed, see? Inactivated and closed.
Calcium channels.
When the sodium channels are closed, the membrane potential will be dropped, see? Phase 1. This is one reason. Closing of sodium channels. What the other reason for the phase 1?
Slow calcium.
See, listen. I have discussed it in cell physiology. Transient outward potassium channels. This is a special type of potassium channel. Transient outward. Potassium channels that are transient outward will be open. Potassium will go out and the potential will be dropped for a very brief period of time. Then, here, fast sodium channels, closed, transient outward potassium channels are open. Early drop. During fast, I mean depolarization, A-type calcium channels, which can carry both calcium and sodium, we call them a slow calcium sodium channels, will also be open. When the amount of potassium that goes out and the amount of potassium that goes in are equal to each other, the cell cannot repolarize. The cell will remain in depolarization state. The amount of potassium that leaves the cell and the amount of calcium and sodium that enters the cell are equal to each other and counterbalance each other. The cell will remain in depolarization. So what is the reason for plateau or phase 2?
Because the amount of potassium going
Uh-huh.
into the cell is the same as the amount exiting the cell.
So what is the special channel for calcium? L-type calcium channel. We have different types of potassium channels that are open during phase 2. In phase 1, transient outward potassium channels are open. In phase 2, delayed rectifier potassium channel. Delayed, in phase 2, delayed rectifier potassium channel. These delayed potassium rectifier channel can be divided into rapid and slow. Mostly rapid are open during phase 2. So, transient outward are open. Rapid delayed rectifier potassium channels are open. L-type calcium channels are open. There is also another potassium channels that are open here. Inward rectifier potassium. Inward rectifier potassium. Are all open during phase 2 in fast response cells. So the amount of potassium that goes out are equal to the amount of sodium and calcium that goes in. So the cell remained in depolarization state. Now see what is happening. After some time, calcium sodium channels will be closed. Potassium channels will also be closed. During phase 2, another reason for the plateau state is that the permeability of potassium channels during phase 2 is 1/5 due to the opening of calcium channels. 1/5 permeability of potassium channel to potassium ions will be reduced to 1/5 during to the presence of calcium ions that is coming into the cell from L-type calcium channel during phase 2 or plateau. Now the calcium channels are closed, but the potassium channels are still open. That inhibitory effect of calcium channels will be finished. Potassium ions will pour out, and then we will have repolarization. Final repolarization can be occurred due to the opening of a slow delayed rectifier potassium channel. A slow delayed rectifier potassium channel. They will be open during phase 2, but first rapid delayed rectifier potassium channel. And then the rapid initiates repolarization. But completion of repolarization is due to the opening of a slow delayed
This is
rectifier.
calcium channel is slow
Pardon?
because calcium channel is slow. So polarization.
Yes, the slow type of delayed rectifier potassium channels are activated. That is why the repolarization is slower than depolarization. Because a slow delayed rectifier potassium channels are activated. Up to here, any questions? Any question? No question. In the new version of Bern physiology book, ultra rapid delayed potassium channel are also mentioned. Ultra rapid. In order to add your information, in 2023 version of their physiology 2, another type of potassium channel is also mentioned, ultra rapid delayed reticular potassium channel. Now, up to here, we have discussed fast response.
I think the ink